right, so what kind of problem is this?
Linear regression.
Right, I have categories here. I do not have labels there, so it cannot be a matrix. I have two lists, so it can't be an ANOVA. And then they're also looking at relationship between blank and blank. So that is totally a linear regression. Chapter 10. All right, so everybody do all 5 steps for this one. All right, so step 1. Step 1 is H naught is rho is equal to 0. H1 is rho is not equal to 0. Great. We want to see there is relationships that are kind of, I'm not going to worry about that so much. Step 2 is my alpha, 0.10. Step 3, we need to do, what kind of test are we doing here?
Linear regression
Yep,
t-test.
linear regression t-test. L1, L2, I think it's like 1 and not equal to. Make sure you also write down the A and the B. Give me the R, give me the p-value, give me the A, and give me the B. Like 3 sig figs. That's good. Okay, and then we'll go over that in just a minute. So again, you'll figure out which one can you control more. Size in square feet, size of your casino, so that's going to be your X, your list 1. This is your list 2, your Y. All right, so then what's my R?
0.445.
0.445? Yeah. P-value?
0.318.
318. What was my A?
63.9.
And B?
0.443.
443. Terrific. Now, step 4. My p-value is way bigger than my alpha, so I'm going to what?
Not reject.
Not reject H naught, which means that there is
Not enough evidence.
not enough evidence to say size, casino size, and revenue are correlated. Okay, so then comes the next thing, right? I need to predict the revenue, the Y, for a casino in Atlantic City that has 190,000 square feet. So 190,000 square feet, is that my X or my Y?
X.
That's my X. So given that X, find the Y. So I'll give you folks a couple minutes to find the Y. If you need it on your, you have your A to B there. You know the linear regression line is Y equals A plus BX. Also on your calculator. I will give you 2 minutes, 1 minute. Okay, so let me see. I think I have this. I'm going to go Y equals A, 63.9, plus B, 24.3 times X, my X being 190. Is that right?
Wouldn't we do 2-bar stat or no?
Yes. This is not a line. We did not reject H naught. It is not a line. Is everyone on board?
Agreed.
So instead we're going to use Y equals Y bar. So we're going to do 2-bar stats. And then stat calc 2-bar stat of L1, L2, and you end up getting a Y bar of what?
134.7.
0.74. Great. $7 million. You should label it $1 million. That is the correct answer. Oops. Good. Nicely done. Remember when we do not reject H naught, it is not a line. So you cannot use a line to predict. You would not use the y equals a plus bx to predict it. Instead, my best prediction, if there's no correlation, is the average y. My best prediction of y is the average y. My best prediction of x is the average x. And then, next we're going to take a look at, we did 20 already, so it pops us up to 21, which is here. 21. And we said already that this was a chi-squared matrix. So I would say, and again, I strongly recommend with the chi-squared matrix to go ahead and make your matrix. But do you want to go ahead and do one quickly, just to make sure we get it? Just do find H naught, and then do step 3, just quickly, just so we have practice with it. It's been a while since we've done one. So again, if you can't remember how to get into the matrix, it's second, and then you go down to the 4th spot to hit matrix. I'll show you. Here. So, second, down to matrix. Do not mess with the names. Go over to edit, hit enter on A, and change it to the size you want. If you want 3 by 3, make it, change this to a 3. Change that to a 3. Remember, it goes row then column, RC, like RC colon, row then column. And columns are the ones that go up and down, like for a house, to hold up a house. Okay. So we've got our H naught. What's our H naught for this one?
O sub I equals E sub I.
E sub I, or you could say independent if you want to as well, that really works. And then our step 3, we're going to do our chi-squared tests, and we end of matrix A, square brackets, and we end up with a chi-squared of 30.7 and a p-value of 3.53. And again, you cannot have a p-value probability more than 1, so darn well better be an E negative at the end. It's E negative 6, which means that you put 6 zeros down, and then your 353. This place goes after the first 0. Now don't forget, also with the matrices, you need to give me the first and last expected values. So please find those also. Give you 1 more minute for those. Okay, so the first one is E of the first row, first column, the very first one. So that goes with this fellow here. We're going to take his row total and his column total, divide by his grand total. So 119 times 246, in either order, it doesn't matter, divided by 582. And for that one, you folks got what?
50.29.
50.3. And then the other one is E, the last row is 3, the last column is 3. So again, you're going to take, that's this guy, you're going to take his row total and his column total, divide by the grand total, and for this one you got what?
131.96.
131.95. Okay, good. Perfect. All right, so now let's take a look at the next problem. Number 22, the shopping bags. What kind of problem is this one?
Golf.
What do you folks think? There are proportions. So there's some proportions going on. So, but I've got 60%, I got 30%, I got 8%. I have too many proportions. I got 3 proportions. So it can't be, I like the fact you see it's proportions, I've got 3 or more, so, yep, goodness of fit. Does everyone kind of follow that? This is goodness of fit, because I don't have a matrix. So it's got to be, since it is proportions, and I've got 3 or more, then it has to be one of the chi-squared, and I don't have a matrix here, so it has to be goodness of fit. There's enough stuff here. Okay? So that means I'm going to need to make my own. My options are reusable. So write this down, reuse, plastic, paper. I want you folks to find the observed and expected. That's all we're going to do for this problem. We're just going to do that. So find the observed and expected values for this. Actually, we'll go ahead and figure. I'll give you the observed. The observeds are 120 plastic, 28 paper, and the rest. I subtract from 300 to get 152 observed. I want you folks to find the expected. That's the key part of this one. So take a minute, find the expected values. Okay, so reusable is 60%. So is it just 60? Just put 60 in here like that? No? Oh no. Oh shoot. Okay, good. That was stressful. Do I do 0.60? No. I do 60% of what? 300. Of means multiply. So you multiply those, you get 180. Same thing here with the plastic. What is that? 32% of 300. 96. And this one is 8%. 8% is 0.088 cents, not 0.8. Times 324. Good. But remember, these can be decimals. And they are decimals, and you need at least one decimal place. All right, so next we're going to take a look at the multiple choice ones. Number 23 was as the p-value gets larger, evidence against H naught gets what? Take a second with your neighbors. As my p-value gets bigger, larger, what happens to the strength of evidence? Do I have more evidence or less evidence? What is it? Less evidence. Remember, a small p-value means that I have more and more evidence, right? It means my H naught is less and less likely to be true. So, what was that phrase? P-value is low, H naught must go. Toss it out. So, if p-value gets larger, I have weaker evidence. So this would be less strong. Number 24, if all else remains unchanged, a larger sample size affects a confidence interval, has what? The width of a confidence interval becomes what? Larger, wider, narrower, or no effect? So talk to your neighbors about it. Or did you already talk to your neighbors about it? Talk to your neighbors about it. What happens to it? So the larger sample size. So in terms of hypothesis tests, the larger my sample size, the kind of the better evidence I have. Does that make sense? In terms of my confidence interval, the larger my sample size, that's more about evidence. Tests are about evidence. Confidence intervals are more about error. So the larger my sample size is about error. Do I have less error or more error? Less error. The larger the sample size, the more sure I am. Does that make sense? So, larger the sample size, the smaller my error. So remember, error is, my confidence interval is you take your middle spot and you add and subtract your error. The smaller the error, the smaller the narrower my confidence interval is. narrower. And then the last one, if H naught is not rejected, at alpha 0.01, what about alpha 0.05? So talk to your neighbors about that one for a second. Okay, so what was your answer to this one? So here's what I would do. If H naught's not rejected at alpha 0.01, I'd write down my p-value, and I'd write down 0.01 and figure out which one's greater. If it's not rejected, which one's bigger? The p-value. Okay, so then what does that tell me about the p-value compared to 0.05? If the p-value is larger than 0.01, what does it tell me about the p-value compared to 0.05? Not enough information. Does everyone kind of follow that? What if we do reject and alpha is 0.01? Take a second with your neighbors and figure out that one. What if we did reject it at 0.01? What about if alpha is 0.05? All right, so what do you folks, so again, I would do this. I'd write down my p-value. My alpha is 0.01. If I reject, is the p-value smaller or larger than 0.01? If I reject,
It's smaller.
so then what's up with 0.05?
It's still going to be smaller.
It's still going to be smaller, so then what, should I reject or not reject?
Reject.
Reject H naught. Does everyone kind of follow that? You need to know all the variations. Okay? What if H naught is not rejected at alpha is 0.05? So now we're going to take 0.05 and 0.01 on your paper and swap them. If we do not reject alpha at 0.05, what happens if alpha is 0.01? 15 seconds with your neighbors. Again, I'd recommend comparing your p-value to alpha to 0.05 and then see what it means with 0.01. Okay, what'd you folks come up with?
It's going to not be rejected at 0.01.
Correct. If the p-value, so if I do not reject at 0.05, what's bigger, the p-value or 0.05?
P-value.
P-value. So then, am I going to reject it when alpha is 0.01? No. If we don't reject at 0.05, we're definitely not going to reject at 0.01. Do not have enough of this. Good? Okay, so the last one, 27, just tell me what kind of problem it is and what would you write down for your, what would be your, so tell me, what kind of problem is this? It's a test, yep, so it's a test, and it is, what kind of test is it? Mean, yep, so it's a mean. So what is going to be my calculator function? T-test. All right, so everybody do the first thing, tell me what is my claim, and then what am I going to put inside t-test? Those are the only two things I think we need. Okay, what's my claim? What's the claim? U is equal to, yeah, it claims that the wind speed is 8 miles an hour. U is equal to 8. So then what numbers are we putting in the t-test? Go ahead and try it. I'll pop over here. So t-test asks for, we're going to be statistics. It's going to ask for my mu naught, my x bar, and my s and my n. So what would this be? My mu naught? 8. 8.2, 0.6, 32, and my H1 would be not equal to. Good? All right, that is it. We're good.